All right, welcome. Today we're doing something really cool. We're going to move beyond just writing basic commands and actually give our C programs, well, a brain. We're going to teach them how to make decisions and repeat actions all on their own. Let's get into it.
So let me start by asking you this. What if your code wasn't just some simple to-do list that runs from top to bottom? What if it could actually react to situations, adapt, and solve real dynamic problems? That's the huge leap we're about to make.
On one hand, you've got this linear code. It's like a straight road. It just does one thing after another, no questions asked. But on the right, well, that's where the magic is. A program that can look at a condition, choose a path, and even repeat actions. That's what separates a simple script from a real-world application.
So, here's what we're going to cover. First, we'll see how to make our code make simple choices. Then, we'll level up to handle lots of different options. After that, we'll unlock the incredible power of repetition. And we'll wrap up by looking at the brand new toolkit you'll have to write some seriously smart programs.
Okay, so first up, creating those forks in the road. How do we get our program to actually look at a situation and decide, should I go left or should I go right? This is really the heart of decision-making in code.
And the very first tool we're going to grab for this is the if statement. Seriously, just think of it like a gatekeeper. It asks a simple true or false question, and if the answer is true, it opens the gate and lets the code run. If not, the gate stays shut.
Okay, let's make this super practical. Here's a simple, everyday problem. How can we get a program to figure out if someone is old enough to vote? This, right here, requires a decision.
Now, before we touch a single line of code, let's just think this through like a human. First, you'd get the person's age. Then you'd ask the most important question, is that age 18 or more? And based on that simple yes or no, you get one of two very different answers. And for this exact kind of this or that decision, C has the perfect tool just waiting for us, the if-else statement. It's so straightforward. If a condition is true, do one thing. Else, do the other thing. And just look at this. You can see exactly how our logic turns into code. If the age is 25, that if condition is true, and boom, eligible to vote. But if the age is 16, the condition is false, so the program just skips down to the else path and prints not eligible. It's simple, it's clean, and it's incredibly powerful. Okay, that's great for a simple yes or no. But what happens when life gets more complicated? What if you have way more than two options? Let's see what we can do about that.
Just imagine a user menu in any app. Press 1 for this, 2 for that, 3 for something else. You could try to chain together a bunch of if-else statements, but man, it gets messy and hard to read fast.
And this is where the switch statement comes in to save the day. It's kind of like an old-school telephone switchboard. It takes one value, like the user's choice, and connects it directly to the right block of code, running only that specific one.
You don't even need me to explain this one, right? The visual just says it all. On the left, you've got this waterfall of if-else checks. It's confusing. But on the right, a super clean, organized switch block. It's way easier to read and, believe me, a whole lot easier to maintain.
All right, so our code can make decisions. That's huge. But now, let's teach it how to do the heavy lifting for us by automating all those repetitive tasks. This is where you really start to see some amazing efficiency.
So, think about this. Let's say you need to print a multiplication table. Are you really going to sit there and copy-paste the same print command 10 different times, just changing one little number? No way. There's got to be a better way, right?
And of course, that better way is a loop. A loop is basically your program's automation engine. You just give it a chunk of code and a rule, and it will just keep on running that code over and over until the rule isn't true anymore. It does all the boring work, so you don't have to. Now, C gives you a few different kinds of loops, so how do you know which one to pick? Well, it's pretty simple. If you know exactly how many times you need to repeat something, the for loop is your best friend. If you need to keep going until something changes, you'll want a while loop. And if you need to make sure the code runs at least one time, that's the special job of the do while loop. Okay, so for our multiplication table problem, we know exactly how many times we need to repeat the calculation, right? 10 times for the numbers 1 through 10. That makes the for loop the absolute perfect tool for the job.
So let's really break this down, because this one little line is the whole engine. That first part, int I equals 1, that's just the setup. We create a counter and start it at 1. The middle part, I less than equal to 10, that's our rule. The loop will only keep running as long as this is true. And that last bit, I++, that just means add 1 to I after every single pass.
And boom, here's the result. That one little for loop did all the work and generated the entire table for us. Every time it looped, I went up by 1 and it just printed the next line of the table. That's automation right there.
Okay, let's just pause for a second and take a look at the powerful new toolkit we've just put together. These aren't just random commands. This is a complete system for controlling how your program behaves.
So, let's do a quick recap of your new toolkit. When you've got a simple this or that choice, you're going to reach for if-else. If you've got a bunch of different options, switch is your clean, organized friend. And for anything that's repetitive, you've got a whole set of loops to put your code on autopilot.
And I really want this to sink in. Mastering if, switch, and loops, this is the moment you go from just writing lines of code to actually building logic. This is the absolute backbone of pretty much every piece of software you've ever used.
So I'll leave you with this thought. You now have the fundamental tools to make your code think, decide, and do the hard work for you. So the only real question is, what problem are you going to solve first?